All right, so let's look at example 1. We're going to compute the linear correlation coefficient for the height and weight pairs plotted in figure 10.2. So we are going to use this data and get R squared. All right, now we may have noticed up above, it's a very tedious process. We have to make an x squared column, a y squared column, and an x times y column. And then we have to put all of our calculations into the appropriate pieces of the formula, and it's a very long, tedious process. Instead, let's use Excel to get this value rather quickly. All right, so I'm going to take my information here, and you'll notice I'm not copying the very last piece because that's the total. I'm just copying the data itself. So I'm going to copy and paste this into Excel. All right, so there it is. All right, now we're going to use that data to find the linear correlation coefficient. So we're going to use equal, and we're not actually going to find the coefficient. We're going to find the squared coefficient. All right, so this returns the square of the Pearson product moment correlation coefficient. You'll notice it says, all right, and what I'm going to enter is, notice that it's calling for the y's first. So my y values are actually here in the B column. So I'm going to tell it B1 to B12 is where the last one is, and a comma. And now I want to tell it the x's, which is in the A column. So A1 to A12, oops, A12, and hit equal. Now, this is the square of what I need. So now I'm going to take the square root of this to get the actual linear coefficient, correlation coefficient. All right, so let's take the square root of 0.754057, and that gives us the actual R value is 0.8684 if I round to 4 decimal places. All right, now, if this number is close to 1 or close to -1, we have a strong linear relationship. All right, and we're going to call anything, for our rule of thumb, anything greater than 0.7, we're going to call that a strong linear relationship. Now, in this case, it's a strong positive relationship, whereas if this had been a negative 0.8684, and let's realize that when we take this square root, we're always going to get a positive value. So what we want to check is that as these values go up, are these also going up? And they are. So this is going to be a positive square root. If these values on the left were going down, we would get a negative square root, and so a strong negative correlation. So be careful that you watch whether these are going up or down. In this case, they're going up. So this is a strong positive correlation. If these have been going down, we want to express this as R equals negative 0.8684, and we'd have a strong negative linear correlation.